Good morning, everyone. I am Dr. Serajul, Assistant Professor, Department of Chemistry, Langat Singh College, Muzaffarpur. Today, in this video, I am going to talk about structural theory in organic chemistry. For the refresher course in chemistry, UGC Malviya Mission Teacher Training Center, Nainital. So I am very thankful to the UGC MMTTC for giving me this opportunity to talk about the structural theory in organic chemistry. So I will talk in this video bond fission and its types, organic reagents, types of organic reactions, inductive effect and its applications, and mesomeric effect and its applications. So what is bond fission? You know, a covalent bond is formed when two electrons are shared between two atoms. Now a chemical reaction takes place when old bonds are broken and new ones are formed. Bond making and breaking takes place by two ways. One way is homolysis and heterolysis. Friend, homolytical fissions or homolysis. In this type of fissions, shared electron pair is distributed equally between two bonded atoms. You can see here this AB bond break homolysis and give the free radicals A radicals and B radicals. In similar way, if you have the chlorine molecules, if you shine light on it, it will give two chlorine free radical. Now, homolytic fission characteristics. It is shown by half-headed arrow like this. Two fragments formed in this cleavage are neutral species and each one has one unpaired electrons. These species are called as free radical. High temperature, light and peroxides are used in homolytic fission for the productions of free radical. The reaction involved in free radicals as intermediates are called free radical reactions and are proposed through the free radical mechanism. Now, heterolytic fissions or heterolysis. You know, my friend, in this case, we can see that one of the atoms carry a negative charge after bond cleavage, indicating that it has both the electrons of the bond and the other has no electrons at all. Hence, it is electron deficient, thus positively charged. As the electrons are not divided equally after bond cleavage, this is called heterolytic fission. My friend, heterolytic fissions, in a case the carbon atom carries a positive charge, it is called a carbocation. And in the case it carries both the electrons of the broken bond and is negatively charged, it is called carbanion. You know, my friend, carbocation and carbanions are the most important carbon intermediate in organic chemistry. So, types of heterolytic fissions. This heterolytic fission takes place in two ways, based on the electronegativity difference of the two atoms in the compound. You can see in this example types of heterolytic fissions. If B is more electronegative than A, then A plus and B minus. For example, CH3Cl, so CH3 plus, which is a carbocation, and Cl minus. If A is more electronegative than B, then A minus and B plus. Here you can see the heterolysis formation of carbanion and H plus. So, organic reagents. There are three types of organic reagents. Electrophiles. These are electron deficient species and attack at the center of the maximum electron density at a negatively charged center of the molecules. And these act as Lewis acid. Electrophiles are of two types, positive electrophiles and these carrying positive charge, You can see here the H plus, Cl plus, NO plus, and neutral electrophiles. These are the neutral species like AlCl3, BF3, like this. My friend, what is nucleophile? And these are the electron rich in a species and attack at the center of minimum electron density or at positively charged center of the molecule. And these act as Lewis bases. Nucleophiles are two types. Negative nucleophiles, these are carrying negative charge. For examples, all carbanion H minus, OH minus, Cl minus, and neutral nucleophile like neutral species like ammonia and H2. My friend, free radicals, and these are the neutral species and contains an unpaired or odd number of electrons. These are produced by homolysis of the covalent bond. And free radicals are paramagnetic in nature due to presence of odd electrons like Cl free radicals. Now, these are the neutral intermediate formed due to the homolytically cleavage of a single bond. And some common bond which cleave to give free radicals in organic chemistry are shown like CO, CCl, CBr, Ci, CC, CH. Now you can see there are two structures. One is the pyramidal and another one is the planar. So if it is a pyramidal, then it is sp3, and if it is planar, then sp2 free radicals. Now come to the point like the carbocations. You know, carbocations are formed from the heterolytically cleavage of a carbon heteroatoms bond where the other atom is more electronegative than the carbon, like a CO, CN, CX. X can be chlorine, bromine, or iodine. After the cleavage, if a carbocation is to be formed, the 2 electrons of the bond must go to the other atom. And this is the favored if the other atom is negative, electronegative formations of carbocations and be assisted by using cations. Now, my friend, come to the carbanion, and these are the intermediate form as a result of heterolysis. But here the electron pair form from the bond is kept by the carbon atom. From what we saw earlier, the more electronegative atom keeps the electron. So in this case, electron must the more electronegative of the atom, 2 atoms making up the bond. You can see the pyramidal structure of carbanion and the hybridization sp3. Now organic reactions. There are 4 types of organic reaction: substitution reaction, elimination reactions, addition reactions, and rearrangement reactions. So what is the substitution reactions? In substitution reactions, one atom or a group of atoms is substituted by another atom or group of atoms to form a new substance. Example, CCl bond, in which the electron atom has partially positive charge due to the presence of highly electronegative chlorine atom. In a nucleophilic substitution reaction, the nucleophile must have a pair of electrons and also should have the high affinity for the electropositive species as compared to substituent which was originally present. You can see here the cleavage of CH bond. So, first, elimination reactions. There are some reactions which involve the eliminations or removal of the adjacent atom. After these multiple bonds are formed, there is the release of small molecules as products. One of the example of elimination reaction is the conversion of ethyl alcohol to ethylene. You can see in these reactions the formation of ethylene. In the same way, my friend, addition reaction. This double bond will convert it into single bond. This is the addition reaction. Now you can see the rearrangement reaction. You have the pinacol and formation of pinacolone. It is a type of rearrangement reaction. Now you can see the inductive effect. Inductive effect is defined as a permanent displacement of electrons pair in a sigma bond toward more electronegative atom or group in a carbon chain is called as inductive effect. It arises due to electronegativity difference between two atoms forming sigma bond. It is transmitted through sigma bonds and its effect decreases as the carbon chain length increases. Significance up to 3 or 4 carbon atoms. After that, it is negligible. It is denoted by this. You can see the Cl. So this is the example of inductive effect. Now you see the types of inductive effect: negative inductive effect or positive inductive effect. In the same way, what is the application of inductive effect? You can see the stability of carbocation and stability of carbanion and acidic strength of carboxylic acid and phenol on the basis of inductive effect. Basic strengths of amines we can explain on the basis of inductive effect, and mesomeric effect or resonance effect. You can see here these two examples. So easy questions you have to make, like define inductive effect, write two applications of inductive effect, explain mesomeric effect, explain hyperconjugation with two applications, explain types of organic reaction. And short answer type question from this lectures, like the write about types of bond fusion and with example, explain the following: electrophilic, nucleophilic, free radicals reagent, and explain the stability of carbene based on hyperconjugation. So thank you very much. I'm very thankful to the MMTC Nainitals to give me this opportunity. So I am thankful to you all.